Hello, welcome to our talk on harvesting the cosmos and sky farms and the green road to space. First, I'm Adam Williams. I'm a PhD student at the University of Minnesota, studying the transformation of lunar regolith into soils to enable space agriculture. Also work as a professional engineer. I have a broad educational background you can see here. Mate is Michael Williams. We are brothers. Michael works as a systems engineer, currently supporting NASA and DoD work. He has a master's in systems engineering from the University of Maryland and is completing his graduate certificate in space resources this spring from the Colorado School of Mines and going on to do his master's, his second master's in space resources. We're led by Professor C. Yang. C is my PhD advisor. She's an agricultural robotics specialist and associate professor at the University of Minnesota in the Bioproducts and Biosystems Engineering Department, with a specialty in agrobotics and precision ag and the associated technologies with that. So really, when we get into it, space settlement is limited by three things: access, economic use cases, and populations. And they're limited inherently by the physical limits to launch, the tyranny of rocket equation. This in turn limits humans to be in space because humans are in many ways chemical rockets, and we need calories to support our population levels. And that support is inherently limited by launch. There's also potential issues around, why should we do this in space versus Earth? Environmental factors on Earth we need to consider, and human wellness. A lot of data here, but really the short is that research we have shows that nutritional and calorie needs in space are much the same as on Earth, and in many ways space is more demanding, so we need to have high quality nutrition. Otherwise, food will become the bottlenecking issue for space habitation. So enter the Sky Farm. The Sky Farm's a modular ring that can be placed around a space elevator and serve as the backbone for orbital food production. They have essentially unlimited grow light, and water can be sent up the elevator from Earth, as well as air and other things. And then food is produced there in this controlled environment and can either be used in space or sent back down to Earth, and functioning in many ways as a spaceport to service the space economy. Space elevators are a great idea, right? The elevator is the safest mode of transportation. We travel more on elevators than rail and air combined annually. The fatality rate of elevators is extremely small compared to the 1% possibility of space flight. And the safety incentive alone is really enough to pursue space elevators, to say nothing of the economic advantages. Do you want to call out and thank the ISCC's body of knowledge around technical feasibility and establishing credibility for the concept of space elevators? In particular, the Climber architecture and the Green Road to Space annual report weighed heavily into these concepts, as well as the What is a Space Elevator article. When we think about the design and engineering challenges, space elevators are usually the largest structure in human history, certainly the longest. There's a tremendous amount of risk, but opportunity as well, and these can be mitigated using digital engineering and automation and other technologies to mitigate any kind of security and design concerns. We also know that we can grow food in space. So NASA's done a lot of work since the 80s, 90s, and here we see a photo of an astronaut on the ISS harvesting veggies from their veggie system. So we know it can be done. Certainly, there's more technical work that needs to be done, but the proof of concept is there, as well as the work around using space soils. There's a lot of benefits to sky farms. They can work in conjunction with space elevators, serves as logistics hubs. There's the controlled environment that we can use to control temperature and humidity and all sorts of other factors when we're growing these plants. We have unlimited solar power, either directly from the sun using mirrors and shutters, or we can also just have solar panels around the farm to support the grow beds and other technology. There's also lots of interesting applications for altering spin gravity, right? We can maybe at harvest time spin down the gravity and the veggies all float, and it makes it easier to scoop them all up, for example. Some plants may grow better in lower gravity or higher gravity. Certainly we need more work around that, but it gives us lots of options. There's also good options around the moon, right? If we put the space elevator and Sky Farm on the moon, it would serve as a logistics hub over there. It could be built using currently available materials. and immediately brings benefits to the cislunar economy, having to avoid the pesky problem of landing on the moon or shipping food over from Earth. And when we look at the original concept of an anneal cylinder, the discussion there was around using soil from the moon. So all the better to support the growing space habitats, orbital habitats around the cislunar space. So that gets us to the primary value, which is gravity well trade, right? Water and air go up, food and bioproducts are produced, and they come down, and they can go out and support growing populations and addressing food scarcity. So just conceptually here, we can just kind of see the materials coming up from Earth, the light's coming into the various disks, and that's going down to support Earth or out to some other habitats or to other orbital habitats around the space elevator in near Earth proximity. So basic concept here, I think kind of demonstrates in another way what we're discussing. Sky farms serve also as another backbone for space exploration, and I'll just throw out the concept of what I call a seed, or a space exploration expansion device. Much like a dandelion seed on the wind, this combination of sky farm and space elevator could pack up materials from Earth and head off for Mars or some other planet and arrive and ready to go. You don't need to set up the farm on Mars. It's you brought it with you, and you can just attach the elevator and away you go. This model could go anywhere, right? Go to asteroids. It can go deeper and deeper as long as you had enough mirrors to concentrate the ambient sunlight. The further out you got, it should be able to scale. Oh, these can serve as economic hubs. They're efficient and eco-friendly, immensely scalable, combined with precision ag and AI. And they, people don't know sometimes, but economia is bread. It's the Latin root for bread. So economics is the science of bread. So we're not going anywhere if we don't have food. A lot of green advantages, right? That sync with the sky farms. Substantial advantages to Earth's economy and new frontiers of agricultural production, enhancing global security around food, stabilizing prices, but also green tech with getting these systems to run and resource efficiency. There's no wastewater in a sky farm. Everything is reharvested, reused in a part of a circular economy that many of us aspire to see on Earth. Oh, just running through the numbers. If we imagine a productive space of 100 meters in diameter, that would give us about 7.8 thousand square meters. If we're using half a liter of water daily, we'd need 1.8 million liters. This turns out to be about 2,000 tons of water, which easily fit in the ISEC climber models. In terms of calories in kilograms of food, 500 calories a kilogram, we'd get about 7.8 million calories, which is about 10 people. So that's really not a lot of space when we're talking about space elevators and the volumes we can scale to. And really, it just shows that at a price of $1,000 per pound to orbit, we can produce this crop at economically viable prices. Certainly for the space market, right? Anything going out to the moon or beyond doesn't need to fight with the gravity well. And even potentially, we can get so efficient that we can serve the Earth market as well economically. There are risks and limitations we always need to consider. How's microgravity, crops, system design, technical risks, budget risks. Biosafety is a risk that we need to be very concerned with, both safety to the sky farm, safety to space, safety to Earth. So a lot of thinking needs to go into that area, and resource availability. But all of these can be mitigated. And so as we look ahead to the future, sky farms are the entry and exit points. They're the seeds of the Dyson swarm and the staging areas and general stores of the space economy. And we do need to really focus and be aware of biosafety. So in conclusion, sky farms are a viable concept when paired, particularly they're viable on their own, and when paired with a space elevator, they become very, very viable. The ISEC climber architecture in particular supports this from a physical demand point of view. The basic conceptual model shows certainly economically viable for space and potentially even viable for Earth markets, particularly with regards to bulk dehydrated grain. And they can serve as the basis of space exploration and habitation into the future. So here are some of our references, and thank you.